This podcast is brought to you by Infrastructure Masons, uniting builders for the digital future. The podcast you're about to listen to features a panel of experts hosted by the iMasons Innovation Committee and attended by our members. We're making this content freely available for everyone's benefit. If you'd like to join future discussions and ask your questions live, become a member today at imasons.org/community/members. Enjoy the conversation.
Good morning and good afternoon, everybody. It's a real pleasure to open today's panel, and we're going to bring in our panelists in a minute. Before we go there, I just wanted to give you a bit of an introduction to the format of today. We're going to have three panelists. We've invited them to actually talk about powering the future, renewables, resilience, and the new data center playbook. We've actually opened this panel to everyone. So if you're coming from LinkedIn or you've received an email that was telling you about the panel and you're not yet an iMasons member, first of all, welcome. We're more than happy to have you here. The next panels will be reserved to iMasons members. So if you find the discussion interesting and you want to continue coming to the next panels, then by all means, become an iMasons members by going to imasons.org and clicking on the join button. So without further ado, I would like to, first of all, bring all of our panelists today and also give you a bit of an introduction. We know that power has been a hot topic for 2 to 3 years now. Grid operators across the world are now saying there is no more power on the grid, and data center operators are saying, we still want to build them. We still want to go to market. There is still a lot of demand out there to be answered to. So with that, there is new forms of power generation, delivery, and ways of acquiring power that has been forming. We've brought you actually 3 different visions of what the market is composed of, and people that actually work in that segment very specifically. It's not all straightforward, and this is why we brought in the expert. So I look forward to actually now introducing our 3 panelists. First of all, Dan, welcome to the panel today. You're the CEO and founder of RE24, an enterprise platform for data centers to procure renewable energy directly from power generators.
Hi, all. Great to meet you all. So we at RE24, we are all about getting 24/7 renewables for the data centers. And we believe it's a journey. And from 100% annually matched renewable energy to hourly matched renewable energy, we are going through the journey.
Excellent. Thank you very much, Dan. Next, Joel Wynn from Southwire, VP of Data Center Solution Sales. Southwire is a leading provider of wire, cables, electrical products, engineered solutions, and field services. Joel, welcome to the panel. And finally, Pete DeSanto, Executive Vice President of Data Centers at Enchanted Rock. Enchanted Rock is a recognized leader in reliable, large-scale on-site power and microgrid solutions.
Yes, thanks for having me here today. And as always, a sexy topic to talk about is power generation behind the meter. And so glad to be here. And thank you, Roman.
Yeah, fantastic. Well, welcome the 3 of you on the panel. Once again, if anybody has got questions for the panels, please make sure to put them directly in the chat. And let's get straight into the topic. So we know the strategies to get power, or even resilient power and sustainable power, has been evolving over the last few years. Would you guys care to actually tell us what strategies are emerging, what's becoming the norm, if there is one, and is it something that's worldwide, global, or something that's more localized?
I'll take a crack at it. You said one thing, Romain, no more power on the grid, and I would contest that there's no more firm power on the grid, meaning that there's a lot of power on the grid, but not enough firm basis, meaning there's 5% of the year or 7% of the year where you can't offer that firm capacity. And I would contest that with the right behind the meter solution or bring your own power mindset that we're seeing. The data center can build that on site generation, and then use that and strategically, thoughtfully flex that back to the grid for that 5 to 7% where the grid can't be firm, and actually get connected faster to the grid. And when you get connected faster to the grid, that's the green renewable energy that's on the grid. And from a carbon emission and carbon intensity, you want to be as connected to the grid as fast as possible on that interconnection versus being in a bridge period of I have to bring my own megawatts and be in a long-term self-generating mode and get that as short as possible. So I wouldn't necessarily say there's no more power. It's just not consistent firm capacity, and you got to make the difference. You got to do the last mile, so to speak.
Thank you, Pete. Dan, Joel, do you want to comment on this and take us through your perspective?
Yeah, actually, earlier we had a really bad echo, so now I think it's somehow it fixed itself, which is fantastic. Romain, would you mind going to the question again? Sorry, with the echo, lost it.
Yeah, absolutely. And for everybody, the echo is my fault, so we'll make sure to fix that for next time. In the meantime, I'll go on mute every time I'm not speaking, so that's not changing anything. What are the strategies, Dan, that you're seeing today from your customers or the people you're talking to around how to procure and balance the cost between reliability, sustainability when procuring the power for next gen data centers?
Oh yeah, fantastic start for our discussion, that one, because previously grid connection wasn't that much of a scarcity. There was plenty of grid connection, and now grid connection has become the hot topic, and everybody is looking for grid connection. Increasingly, what we see is that when grid connection is a constraint, people, I mean, as Pete was going to people go into behind the meter generation, and typically the behind the meter generation could be things like the gas fired generation, but also we see increasingly it's actually the renewable based behind the meter generation too. So for example, we see if you want to have a 50 MVA connection, we see a 50 MVA energy from waste plant being connected to a data center, which gives the perfect behind the power generation in there. And then once we have the grid connection, again we touched on that earlier, then from a marginal cost of generation, renewables is the cheapest option. So then obviously the kind of best option is to go through the renewables once you have the grid connection with the very low marginal cost of generation and with the sustainability credentials there as well. So it makes perfect sense through the renewables. But then the next layer of that, my last point, the next layer of that is that actually how do we get it even more cheaper? So the even more cheaper approach is that buy through the long-term commitment of the renewable energy, but also buy through getting that hourly matching of renewables and then going through that journey. So by doing so, we actually aggregate different technologies to make it very cost effective and sustainable for you.
And I'll provide a different spin on this, since Southwire Company is actually the interconnective aspect of this. If everyone looks at Romain's picture behind him, those transmission lines are really what we're talking about from the grid side. And those right-of-ways are the most valuable piece of assets that either IOUs or public power companies have. So not only increasing density on the data center side, which is going to require short-term gaps, to Pete's point, on islanded power on the generation side, it's also how do we actually move that power in a more efficient way. And Southwire is the largest wire and cable manufacturer in North America specifically. We have launched a new product called C7, which is an overhead transmission line and a distribution cable that's a composite. We won't get too far into the engineering, but it actually increases the amount of ampacity that can be moved on the transmission lines, lowering loss, and also having a longer life cycle due to its reduced weight. A few benefits there are that you don't have to upgrade the infrastructure on the tower side if it is overhead, and that actually allows for more pass through on those very valuable assets to move this increased power that Pete and Dan are talking about outside of an islanded situation, even if those become net profit centers in the future, if that backup is returned to the grid.
So that was, I mean, very different perspectives. And first of all, thank you all for already telling me I'm wrong on my view that the grid is out of capacity. That's exactly what we get the specialist on the call, and I'm not the one actually giving any knowledge today, because I'll make those mistakes over and over. But I want to bring you back onto something. We know at the moment, or we've generally classified two ways of powering a data center, either on grid or actually through either microgrid or behind the meter and so on. Is that an all or nothing? Is there a midpoint? Is there somewhere a timeline of evolution that happens between the moment the site's created and its maybe final stage later down the line? What's there? What do you see in the market today?
I'll take first crack again. There are some self-generation projects that are out there, and again, it's when you think about the site selection and going in that direction. I mean, sometimes you have to be co-located near the gas, and you say, "Hey, I have cheap gas and there's no transmission because I'm at the gas production." So there's some uniqueness to the site selection where you would even want to potentially self-generate for a long duration. And also, what assets are you bringing on site, right? What's the heat rate of the assets, and what does that stack look like to go in that direction? Because the one thing I would say about self-generating forever and using potentially natural gas and a mix of other assets on site, like renewable, like Dan was saying, do you want to take on that fuel risk for a long duration amount of time, like meaning 12, 14, 15 years? And what does that gas contract look like? And you take on some risk that you don't have a crystal ball on what the fuel cost is going to be. Does gas go from $4 an MMBTU in the scale? Does it sometime in the horizon go to $12 an MMBTU? And you're like, oh my gosh, I want to be grid connected now. So I would just think the overall plan. But all that being said, it's not an all or nothing. I just think you have to have some forethought in the beginning. Like what Joel's saying is there's improvements in some of the ampacity of the poles and wires, that at some point there's this ecosphere of data centers going from a grid liability to being a grid asset, and sharing that power in some from a perception point of view to help the community, but also just make it more financeable. You have all this resource that you have behind the meter. I mean, I'd rather use it and run it, but in the right, the right permits and with the right interconnectivity, you get a little bit more juice out of the squeeze, so to speak, for having all that investment in your on-site capabilities. That's a lot to unpack there, but.
So what you're basically saying, Pete, if I just want to uncover that a little bit, is that you're generating power on site for the data center is one thing, but you build an amount of capacity, the data center will utilize a percentage of it. What you're saying is, if we're going to put the capex in the ground, if we're going to build it, we might as well just fully utilize it. And at that point, the conversation is almost in reverse. Back to the grid, back to the communities next door. We've got that availability. What can we do with it? How do we work? Is that
yes,
the right way to look at it?
Yes, and the one piece to add to that is more. I've seen this more in probably the 6 or 8 months. I know you said 3 or 4 years on the power and the shortages, but more utilities are coming to the table, and there's more. The conversations are with now either utility led or data center colo led or developer led, but the more and more the utility is on the front end having the conversation, or even driving the conversation. And that wasn't necessarily the case 6, 8 months, a year ago. That's a little subtle shift that I've seen.
Dan, maybe a bit of a pointy question for you, but how does that change? How does that change the structure of the contracts that you would have been brokering so far for power acquisition of renewables, when somebody is actually reversing the whole thing and actually generating on site? Is that Can you take us through that model, who are the parties involved maybe, and what those contracts look like?
Yeah, and also it's I mean, there's no like one solution that fits all of one solution fits all. So essentially, it's a very tailored solution based on case by case. So for example, it could be an instance that so initially it's kind of like almost the full development goes on a phased approach. So when it goes on the phased approach, so initially maybe like the initial 50 MVA is getting connected and it's getting commissioned. So the initial power procurement would be based on that one. But then as you phase the development, then you add further 50 megawatts on top of that, and then further capacity adds on top of that. So in a way, it's not that you're like reversing the renewable contracts as such, but it's the other way around. You're actually adding more capacity into the connection. So it's like more and more energy requirements coming in. So it's more and more energy requirement is there. So that's kind of like on the point that you raised, Romain. But then the point that Pete was saying is actually really interesting. We see a lot of things happen from the European context as well. For example, in the Irish, Pete raised the point that we see if you have some on-site generation like behind the meter, you won't actively participate into the grid, but not to be a burden to the grid. And we have some classic examples from like this side of the pond as such. So if you look at the Irish electricity regulator, so CRU came up with some consultation. So one of the things that they said was that if you want to have a new grid connection for a data center capacity, you actually need to have behind the meter generation, but the behind the meter generation should be dispatchable too. So it's not just meeting your demand, but actually it should be dispatchable based on the market requirement, but also it needs to participate in the market as well. So essentially, you're not doing like standard auxiliary service. You're not like doing with being a reserve or being on the capacity market, like adding the capacity. But no, you are actually participating in the electricity market, putting the power into the grid, essentially like making more power available for others. Yeah, so it's definitely getting more interesting and actually like kind of more and more activities happening around like different countries, different geographies when you look at it.
That's a very interesting thing to see, like who is calling the shots, if you will, that the grid operators are now making those demands for whoever wants new connections. Joel, do you want to add a comment on what Dan said?
Well, on both sides of that, since we're on the front end construction side, whether or not that's actual traditional generation or if it is islanded generation, I would have to actually pose a question back, since Dan actually alluded to it, is what does that look like? For example, the Senate Bill 6 in Texas, this might be a good question to Pete, and also Dan's allusion to it in terms of being able to deploy that power or to alleviate any stress that could be on the grid. And it seems that this, if you're not familiar with this, it's around large load customers, which is really directed at data centers and also the crypto mining industry in Texas, is that we're seeing a lot more push towards islanded power solutions that we consider part of the data center ecosystem, and what that actually is going to do in terms of a new market in the future. To Dan's point in Europe, but also I guess my question to Pete and Dan is does that actually become a net profit center if you actually are net metering it back to the grid as we ramp up new capacity of traditional grid solutions?
The short answer is yes. I mean, Enchanted Rock has been doing what I would call a flexible interconnection and dual purpose microgrids in Texas from the inception of Enchanted Rock, meaning that we do the net metering. We have a permission to operate with TDSP, and we put full scale natural gas dispatchable resources that can, in a URI type event, can dispatch to the grid. $9,000 megawatt hour is kind of unique, and you can monetize it that way. But between the ERS programs and the things that are specific to ERCOT in Texas, being able to offset the load and make it invisible to the grid, and then whatever excess capacity of generation you have, you push on the pole for the rest of the community. I mean, it helps make it a lot more financeable and a lot easier to monetize it. And what Dan is describing overseas is where I see that model with Senate Bill 6, where anything greater than 75 megawatts in a grid emergency can get disconnected. It just, to me, strengthens and innovatively strengthens the bring your own power message of don't get me wrong, certain technologies are going to phase out. Like, you don't want to have a gigawatt campus, and I'm going to pick on diesel, and that's my personal opinion. I love diesel, but I have a diesel fleet that I used to operate 150 megawatts of merchant diesel plants. And during Uri, the biggest thing was fuel logistics. Like, how am I going to get the diesel when everybody else needs diesel on site? And we burned over a million gallons of diesel that during that 6 or 7 day period of pricing event because of the grid scarcity with electricity. And I can't imagine 10x that challenge of a gigawatt campus if you're using diesel. So you need some sort of renewable battery, BESS system, dispatchable push button fuel source that's resilient when it comes to that for long duration, longer than 4, 8, 10, 12 hours. And that was like a 72-hour event, 80-hour event in some areas. And all that to be said, Senate Bill 6 is driving that to now you have to have some forward-looking thinking of how am I going to handle those longer than 4-hour events. And I say 4 hours because at a certain point, your BESS system needs to be recharged. You started to discharge, you get to a certain period, and now you're in a recharge, and you need some sort of generation on site. And at the scales we're talking about with, I mean, anything north of 100 megawatts, you're building some sort of mini infrastructure power plant on site that's got to be dispatchable. And beyond just displacing the site's load, having that capacity available in other times. I mean, Texas has it's a deregulated market with a 5-minute price cycle. So, I mean, you'll know when to turn your generation on. There's that price signal that says it's $500 a megawatt hour on the 5-minute market. Well, it's not going to, depending what time of day it is and looking at the curves, you might want to turn on just to exercise the equipment beyond just 30 minutes a month and monetize it and have a generation interconnect. So I see Senate Bill 6 being actually very progressive. And I think the large load should lean into that and just start getting creative on how they want to just lean into it and be adaptive like that, and changing the mindset.
And I'll add to that as well, is that the intersection of our vertical markets in terms of construction, traditional oil and gas, is interesting because very often West Texas goes negative, so you can actually be producing energy at even higher margins. But then there's a sustainability argument to that as well. It could reduce the flaring, and it also could reduce methane leakage along the pipelines that are bringing it to the LNG trains that are in South Texas as well. So you could do both. You can monetize, that and actually help reduce, other warming gases outside of CO2. So we're actually seeing a lot more opportunities, not only the BESS system, but also in these, smaller packaged, simple cycle gas solutions directly related to SB6. And it is migrating. Pete might be able to speak to this. I think you're seeing similar bills being mirrored in the Southeast and also in the traditional Midwest, Ohio markets as well. So it most likely is going to become a national solution over the long term. Is that fair, Pete?
It's fair, yeah. PJM, the different independent system operators, SPP, they're putting more into that dispatchable capacity in some form or fashion, because there's such an interconnection backlog for both generation and load interconnection. So it's the only way to solve it in my mind, is to let's use the stranded assets that are typically there that don't get used, and from a firming of the grid power and untapping the capacity that's on the grid. Going back to the original comment of no more power on the grid, there's tons of renewable on the grid, but it's the capacity factor of when they're available has a shape to it, and they're not always available. So you got to fill in those troughs of, like, just picking on Texas, like there's certain times of the day in Texas where there's 20, 30,000 1,000 megawatts of wind generation. And then there's times in the middle of the summer, there's 500 megawatts of wind generation, right? So let's consume the peaks of the generation that's on the grid when we can, but then also have something that can dispatch to fill in those troughs when sun doesn't shine or the wind doesn't blow, and then you have all of a sudden a shortage.
So Pete, that brings me to an interesting questions, and Don, I'd like you maybe you to chime in on this. So when we're talking about consuming renewable energies from the grid, we often see that as one monolithic block of, you know, a lot of green energy coming in and a lot of people monolithic block like consuming it. Dan, I know you and your team have been doing a lot of work on hourly matching and making sure the electrons are being generated or being consumed. Can you take us through first of all, what does that mean? What are the parameters by which we can say for sure that whatever is being generated is being consumed? And also maybe what are the constraints and maybe some of the less true comments we might read in articles or online?
Yeah. I mean, we simply came from an age that we didn't have loads of renewables back in the days. But then, as Pete was saying, so now increasingly there's more and more green electrons in the grid. So now, like, all the operators out there, so we can move from just using your annual renewable energy consumption based on an annual basis, we can move into an hourly basis. So what we mean by hourly basis is that, so essentially on an every hour as and when you use when you use energy, the operators make sure that energy comes from the renewable sources. I mean, the full credit goes to Google. When Google initiated this thinking back in 3 years ago, 4 years ago, but since then, kind of like, why did the market have adapted that one? So the process, what happens is that essentially it's all about the diversification of the technologies, diversification of the assets. So then, as Pete was saying, so there are times that it's fully windy, and then it's times which is very, very sunny. But even there are times that it's actually sunny but less windy. But then we can tap into other renewable generations like the landfill gas, and then hydro, and part of the energy from waste as well. So by aggregating those technologies together, we can essentially create that portfolio effect. So then the operators, when they use energy, it's actually getting 100% renewable energy. From a infrastructure wise, we don't have to do anything new into the mix, but it's all about aggregating those volumes and then optimizing it, and then essentially shipping that energy for the end users. So they use that energy almost in that real time basis. I mean, as I was saying earlier, a little bit, is that what we always believe is that, like, getting into that hourly match renewable energy, it's not an overnight journey that any operator would go through. It's almost it's a process that people are going through. So the first they will get, if your annual demand is, let's say, 100 gigawatt hours annual demand, so you would try to match that demand from a renewable source, but then you're seeing from an hourly basis, it could be 50% hourly matched. But then what other technologies can you bring in order to make that mix increase further? So if you had a renewables from a wind farm earlier, so then you're bringing a solar generation afterwards, and then you're bringing landfill gas afterwards. So like essentially aggregating those technologies together. I can just add one more thing very, very quickly. By doing so, what we've seen is that we've seen the operators actually reduce the cost as well. Because by making the portfolio effect, you can optimize the volumes, you can optimize both generation and demand, and you can make some significant savings from your electricity consumption.
Thank you, Dan, for all those comments. Very insightful. I'd like to turn to high voltage cabling. One of the things you said earlier, Joel, that was very interesting is that everybody says the grid has got to upgrade. It's got to get more capacity. We've got more to transit. Data center is just one player that is today trying to get more energy out of the grid. And you mentioned innovation happening literally at the core component level in the cables. Can you, so maybe a high level, take us through what sort of innovation you're seeing on that front, but what is it unlocking for every consumer, operator, and so on? Like, what's the change operating today?
So, at its core, the picture behind you is there's a lot of line loss that just occurs just by its nature of just moving electrons, right? And our C7 product is a composite cable that allows, I guess, a condoing aspect for the transmission lines. And so with its higher ampacity and its higher ability to maintain heat and reduce sag, then we can actually, with our public power and IOU partners, move more electrons more efficiently to reduce that loss. And then this is really gonna help the downstream as we start seeing the 800 volt DC architecture enter into data centers, which will reduce a lot of the equipment required as well. The intersection here is that at this current, I guess, gold/data rush that we're in, is that the U.S. grid is at its at its end life for a lot of reasons. And at Southwire Company, we really talk about the requirement of grid hardening. And outside of the data center market, you're going to have, especially as interest rates drop and the need for single and multifamily homes, you're going to increase even more consumption, along with the other trailing market segments like commercial and also industrial, is that we have to get more efficient on the transmission side and also on the product side that's been delivering power for the last 100+ years. Southwire's been in business for 75 years, and there's a 50% chance that your home is being or your office right now is being distributed power by a Southwire product from a grid input. So it's not only on the distribution side, but it's also interior to the building, and we can unpack a lot of other solutions. But the fast approaching epoch in terms of 800 volt DC is going to help alleviate a lot of these things from a loss standpoint of what actually is being produced grid current state.
So if we enable that capacity, that extra capacity coming from replacing or upgrading the interconnects between the grids and the general capacity, is there a point? It's at least general questions for the panel here. Is there a point where any on-site generations become a tap-free measure? Is it installed until the grid goes back to a point where everything can be fed through the grid, in which case that infrastructure becomes redundant?
Yeah, I think my comment on that is a good point, Romain. The first, and as Joel was talking about, a very near and dear topic in the aging infrastructure and all the upgrades, I fall back on it's more and more the need for the large load and the bring your own power to be in communication with the poles and wires, with the ISOs, with the utility, because think about the level of communication and coordination to do those upgrades, right? Because when you're doing an upgrade, there's going to be some period of outage or not, unavailability of the poles and wires of the site. So when you think about that, now all of a sudden I have behind the meter generation that I've been also exercising through a generation interconnection. Like, it becomes more and more valuable to help accelerate the upgrade and moving those projects forward. I know they're doing another transmission line upgrade in Texas. I'll get the number wrong, 845 kV like ring in Texas, and that takes time. But if you were connected to that, there's a section that's getting replaced. I mean, you have to figure out. I mean, you should be in coordination of how long is that upgrade going to take, and if you're, is there a way I can help? And this harmonious collaboration between all the different entities to get it done. And not every behind the meter solution potentially can do that. The scheduling of the gas and everything else you might need if you have dispatchable gas assets, and now all of a sudden you're going to be in a prime period that you didn't expect for 8, 6, 8, 10, 12 month while an upgrade's being done. It's definitely achievable, but again, it's that level of openness and transparency and communication with all the different parties it's going to be more valuable now than it ever has been before. Utilities always used to think that data centers and behind the meter is going to compete with them. It's not a competition. It's a collaboration.
And to piggyback on that, the biggest development in this product is that, again, it gets to use the existing infrastructure so that you're potentially shortening the need to have a T-line tie-in versus actually having to create another transmission line that is a new ring. So again, it's condoing and actually using existing right-of-way other than disrupting and developing new right-of-ways as well, which helps speed to market any of these solutions that help bolster the amount of power that we're going to need, led by data centers, but also by just natural growing of reshoring and manufacturing and growing of the economy into the future, because you can't de-link those two things.
Yeah. Sorry.
Yeah,
I was going to quickly add something into that one. So it's almost like when we look at all that mix, it looks like very, very complicated. I mean, if I'm an operator, and then if I have dispatchable assets, and then I have to dispatch it, I have to take part in the market. It all gets very complicated. And so then like a lot of data centers, most like getting power is a challenge to start with, but then once they have the power, you need to manage it as well. So almost like the question I'm asking like ourselves is that if you are a like hyperscaler, like an operator, you can have a bigger energy team to manage your entire portfolio, but still you have site-specific characteristics to manage. And at the same time, if you are like a coal operator, so you might not have individual, like very tailored energy team to cater all your energy requirements. So I think that's where exactly that like partnership comes in, like working with, like not just working with partners to do the initial construction or like getting the projects commissioned, getting on the ground, but actually partners to be with you throughout the journey, and then getting the power delivered to you. Because I think increasingly that's becoming very, very important, because kind of energy and data, they go hand in hand. So there's definitely very much interlinked to that one.
We've got a question from the chat, and I'd like to bring that up. I'm not sure what that's going to do. Here you go. Look at that. Bright and beautiful and directly on screen. So David, who I've had the pleasure to work in our innovation committee for the last 3 years, is asking, what's the value of battery energy system storage? So where is that? We've talked about generation, transport, utilizations. We haven't talked about storage. Any value in the storage systems at the moment? Are they ready? Are they used? Are they beneficial? What's your take?
I think they're beneficial when paired. Again, it depends. What type of data center? What are they doing? Is it inference? Is it large language models? Is it spiky power? And this sub-cycle fluctuation and on the power consumption. And I would say absolutely. There's no one silver bullet. And I would tell you, rich burn, natural gas recips can meet transient response really, really well. But I think there's an opportunity to have batteries paired with that and have a much more fulsome solution to that. Or fuel cells use batteries because then it's load following. And again, load following is not just set it and forget and have a constant fixed output of it's 500 kW, that's it. But actually following the peakiness or the spikiness of the power. And I think batteries help do that. What I would just challenge from the data center design is if you deploy BESS systems in the proper fashion on site, can we rethink UPSs, right? Is there still a need for UPSs on site if you're now having more of a full scale BESS system on site? And how do you best optimize the stack and the build? Because I would say there's still some folks out there that say, great, build me an on-site natural gas microgrid, but I'm still going to bring my diesels at the data hall. Like, if I built you a 5.9 solution with natural gas, why is there a mindset of I still want to have belt and suspenders from the diesel and having to manage the diesel, like have trust in the gear? I would say the same thing when it comes to BESS, is that if there's an integrated on-site bring your own power solution that deploys BESS in the right way, do you still need UPSs, and how do we sort that out? Does the BESS system become the UPS, and what are the pros and cons of doing that, innovating in that area? But yes, there's definitely some value to BESS for sure.
So,
Yeah.
Thanks very much for putting in the questions. And Dan, we'll bring you in a second. If you've got more questions, put them in the chat. We'll put them on the screen, and we'll make sure that we can answer every one of them. We've got time, right? So don't feel shy. Just put all the questions in. Dan, how do you want to react to this?
Yeah, so that question, even when you look at Pete's example, like if you look at some of the actual use cases, so some of the actual use cases that we have seen is that, so we have seen the BESS systems goes within the DC campus and essentially working on behind the meter. So partly doing a bit of a UPS support service, but also doing the service for the national grid as well. So essentially doing the frequency management or essentially supporting the grid stability. So in a way, yes, so the BESS systems in the DC environment, yes, it is already happening, it's already there. I think the potential is for us is to scale up from there. Like how do we make it a bit more bigger? So maybe Pete have seen, like for example, I haven't seen much on the BESS systems in the microgrid stage implemented at a larger scale. We have seen things at a smaller scale, for example, like long duration batteries on like 1 megawatt, 2 megawatt type of scale, long duration as a proof of concept, or as a proof of concept to get 24/7. Those examples we have seen, but not in that like 50 megawatt region, like on a bigger scale. Maybe it's available in the US market. I don't know.
I know of a couple projects. I won't mention them, but there's some projects on that are operating right now in islanded mode that are using BESS with gas turbines for just that reason. And again, I don't know necessarily the scale of that, but I know they added the batteries after the fact to help dampen some of the spikiness of what large language model they were running. And it had some great impact on what they were doing. So again, not knowing specifically and trying to stay away from some of the names, but they're getting deployed more and more often. They're just for that. If you're getting these subcycle spikes, I mean, there's a couple ways you can handle those subcycle spikes. With something mechanical like a gas turbine can't respond to a 20 to 30% load shift in subcycle. Right, there's not a lot of mechanical things that can go do that. You need something like a battery that can discharge, but then you got to manage the discharge recharge and what does that ecosphere look like? But and don't get me wrong, turbines and everything, they move fast, but is that fast enough for some of the subcycle? And again, how are you handling that? And I know supercapacitors and some other stuff paired. Again, there's no. It's like the bulk electrical grid in general, right? There's hydro, there's solar, there's wind. There's a lot of different sources of energy that also have different operational characteristics that when you mash them all together, you get that diversity that's actually important. And I think we'll see this more and more over time with data center design and build. The challenge right now is there's a little bit of what can I get my hands on to go build this in the supply chain, and that's where I go. That's where the innovation and the magic happens. Is how do I connect? You may not have ever gone in this direction of let's put supercapacitors on site with this and this other thing, and you're like, wow. And now we have some data, and we can, maybe it's not a costly mistake, maybe it's great, but you wouldn't have had that otherwise, right? If it wasn't this power crunch, people are still building data centers the way they did 20, 30 years ago, and utility interconnection and backup on-site diesels. Now all of a sudden that constraint is where the innovation is happening.
Do we see actually a large difference in where the power generation comes from based on the type of data center? Pete, you mentioned AI data centers having very large 20% shift in their power curve demands. Traditional data centers have been a lot more stable. Whether they're small data centers, large data centers, does that change actually the technology or the technical aspects of power delivery to site?
It does, and I'm not going to claim to be any expert on that. I'm more of the mechanical persuasion than I am the electrical persuasion. But you can't be in this space and not understand electrons. But yes, and I mean it's the full stack of you have that BESS system. How long can you discharge it, right? I mean, you have to kind of know. Do you want to? I try to do analogies with cars. Some data centers, you can put the car on cruise control and it's great. You're moving down the highway, everything's great. Sometimes you're in stop and go traffic and somebody cuts in front of you and you need to jam on the brakes, but then you need to speed around them and be a Boston driver and wave to them with one finger. I mean, and those are two different energy sources. Think about the profiles and the operational characteristics. Yeah. Those are two different things. Those are two different cars.
Going back to that point about the UPSs is drawing the line to the 800 volt DC is that it actually just changes the nature of a UPS system so that it becomes integrated. So from a supply chain side is you also have to think about the integration of electric vehicles and what the capacity is going to be for such dense batteries. So it's going to be interesting to see how this integrated system, because the BESS system would become basically the UPS, and if supercapacitors actually take that on, to Pete's point about design, about how wavy and spiky that is, and is that problem actually solved with islanded power in the long term or microgrids? But there is a place for BESS, and it's going to be interesting to see if he wins that race in most designs between BESS and supercapacitors, or if it's a shared opportunity to solve that problem of interruption. But there's a lot of construction of BESS systems, but just like supply side from the line cable standpoint is where actually is the supply chain on both fronts in the next 5 years.
It's funny how life's made. On Tuesday, we organized a pitch competition at Data Center Dynamics London, and one of the companies was actually a supercapacitor company trying to find actually their market position. And they said, well, look, they can be at the server, as the replacement of the UPS, or even bigger as the best system in the stack. But there is definitely people innovating in that space and looking for where they are. We're certainly in speaking to them about how can we get them to connect and find their market and maybe bring in other solutions to it. So very interesting discussions indeed. I wanted to ask about sustainability. I think we've talked a lot about the technical aspects, the requirements. Who drives actually the implementations of on-site versus grid versus and traditional grids versus renewable. Who's driving the sustainability discussions? Are they coming from the data centers and clients that are saying, well, you're now my scope 3 emissions, so you're going to have to do something about it, or is it coming from somewhere else?
What I'm seeing, I can speak to what I'm seeing, is that I don't want to be on bridge power any longer than I need to. Right. And from that, driving the emissions profile and scope 1, and not necessarily wanting to be a power plant, own a power plant, so to speak, but making sure that you're asking for the right interconnection or understanding how much load ramp is going to be there, and making sure that you're having more of the conversation up front. But I'm seeing this shift of, at least with some hyperscalers, of I don't want to be on bridge power for a data center any longer than I necessarily need to be. So it's not so much speed to power, and I see a subtle shift of speed to interconnection. How do I get interconnected to the green electrons and all the renewables that are on the grid as being the best cost, best sustainability option, which is grid power. And that mindset, again, how we get there creatively is what we're solving for today, real time. But it's really that speed to interconnection. How do I get interconnected faster to the grid power, and enjoy the green, low cost energy that's on the grid?
Mm.
Yeah, and if you look at like any operators, any hyperscalers, etc., so they are all fully sustainability driven. So they have a sustainability mandate as from the organization level and from their shareholders' point of view as well, and from the customers' drive as well. So it's driven by different angles. But very interestingly, what we see is that I mean, as Pete was saying, everybody's definitely pushing towards that. Previously has been pushing towards that 2030 scope to zero emission target. And even though with the increasing demand, even though with demand increasing, we still see that those targets has been met significantly like before the actual deadline. So like some meeting the scope to targets now, and some meant to meet in 2028, etc. But essentially a few years ahead of the target. So that's happening on scope 2. And very interestingly, like increasingly we see now it's more data centers are looking into their scope 3 emission reductions as well. So not necessarily like your own electricity consumption, but what the electricity consumption is driven by your customers based on your products. And then when we see that emission reductions, also a lot of projects are happening in order to do that emission reduction from that scope 3 as well, which is really positive because more those things happen, it's actually more and more renewable projects into the grid, and as he was saying, it's essentially making the grid a lot more greener.
From the construction side, it should be well known that the embodied carbon of building out a data center is going to never be overwhelmed by the amount of carbon to actually run the data center over its life cycle. Southwire processes about 1.3 billion pounds of copper domestically in the United States a year. That's very energy intensive. Wire and cable manufacturing is very heavy industry. Southwire has been producing a sustainability report since the early 2000s, and we're on track to be net zero this year. Our hyperscale partners are really leaning into the construction side, whether that's concrete or steel. And just to give an example, we've deployed and first to market with certified UL listed EPDs. And I'll give you just some brief numbers. Very large data center just on the mechanical package, which is a very big part of the load on the balance of systems after the interconnect. This one site in just one section of the job for the mechanical aspect, just the wire and cable embodied carbon is 13,000 tons of CO2 before it is actually delivered and inserted. Southwire is through power purchasing agreements. We're reducing our embodied carbon, but also our supply chain through the environmental product declarations. And we reduced that embodied carbon on the construction side by 29%, which is net savings of almost 4,000 tons of CO2 as well. Lastly, we see this inflection of where oil and gas and generation is going to be. I think it's going to be interesting to see what outside of CO2 is going to be the next frontier if you're getting closer to the wellheads, where fiber grows, and if the islanded power, if you're not exiting the grid, if you're actually able to actually prove that you're reducing methane or that you're reducing escape gas and everything. But Southwire is really working closely on the construction side to deploy data centers that are on the front end sustainable in the construction. And that's certifiable and it's provable out into sustainability reports in the construction side, not just the construction side at life cycle.
That's brilliant. I think we've gone around pretty much a good size of the topic, and we're coming to the top of the hour. So I would like to invite the three of you to make maybe one last comment. Anything you want any of the people listening actually to take away.
I'll just leave with this, and we talked about this a little bit, and Joel brought this up, and just keep an eye on Texas with Senate Bill 6 and what they're doing. There's going to be a lot of innovation. It's the most renewables on any independent system operators in Texas, more so than anywhere else in the United States. So I would just say there's going to be continued innovation in Texas on how we handle the power problem in other areas in the United States, but I'd keep an eye on Texas. That would be my little nugget. And not because I live in Houston, but I would say that. I'd leave you guys with that. I'm originally from Boston. Keep an eye on Texas.
I would say the same thing, and I would encourage those that have influence on specifying listen to the podcast, is to reach out to actually search out these solutions and these design sides where we can help as a manufacturer. But also, if you're advocating for the industry, is that we just have to remember that renewables, nuclear, all forms of energy are going to be required to sustain us through this AI boom and also just general economic growth. So everyone needs to do what they can from their part to help us diversify where we're generating power, and you have influence on that through your investments and also your specification and design position as well. I mean, it's really all hands on deck from conception all the way through deployment with all systems.
Yeah. So maybe my last thing is that, like, even though I've been on the energy sector for 20 odd years, the level of innovation, the level of creativity that we see now is actually like it's amazing. And even in the last 3 months or so, there's things what we have seen happen. We didn't see them happening before. So it's almost like so we always come up with, like, we always face challenges, but it's really fascinating to see how creative we are. So we just need to keep being creative, keep being like trying to find solutions, thinking out of the box. And we've seen case studies. If there's a will, there's a way. Yeah.
Thank you very much for your closing remarks. So just as a reminder for all of our listeners, if you're not an iMasons member already, please make sure you sign up so you can come to the next ones. We've got another 3 panels happening between now and Christmas on very interesting topics. We've got some of the all of them related around innovations, the form factor of data centers, the relations between ESG and the public, and so all of them are actually driven by our innovation committee, but couldn't happen really with the supports of our partners here, actually diligently sharing all of their experience. I wanted to bring a couple more things. So first of all, I mentioned 3 more panels. We've also got a lot more events coming up. If you go directly to the imasons.org website, what you will be able to see there is an events page where you can see everything that's coming up. There is DCD Connect LATAM, Data Center World Singapore, DCD Connect Brazil. There is, we'll be there in Virginia with an advisory council meeting, and there is a Data Centers Island in Dublin where we're doing another pitch competitions with local startups. So a lot to go through, a lot of information. I'm sure the recording will be accessible again afterwards. We're going to push that through our podcast. And so just in case, if you didn't know, we do have actually a podcast series running. If you go to your favorite podcast app, just look for iMasons Innovation Podcast. Unfortunately, you'll have to listen to my voice, but I promise I don't speak much. I only ask a few questions here and there and let people speak. So, or at least I try to. But until then, thank you very much to our 3 panelists. It's been an absolute pleasure to have you on today, sharing all your expertise, and thank you for all of our listeners who have actually tuned in live to actually listen to us on this panel. On that note, thank you very much.
Thank you.
1, 2,
Thanks all.
3, 4.
Infrastructure Masons is a global, non-profit, professional association of individuals connected and empowered to build a greater digital future for all. If you too want access to networking events, forums, and summits that foster innovation and influence, register now and join the other 6,000 committed participants at immersons.org/membership application.